Hello students, welcome back as we continue our adventure with radicals. Today we're going to solve radical equations. And so we've been solving equations all along here. Now this time we're going to continue solving them, but with radicals kind of strewn throughout them. And occasionally we're going to run into something that has some extraneous solutions. We've got to figure out what that means and play that out. So in this particular situation, the expression for D in this broken wall situation here, the variable has a radicand in it, so we end up with a radical equation. It might be radical, but not impossible. So let's work through ones like this. So we got to first, if you see a situation like this where there is a radical as part of the equation, we got to solve it by isolating the radical. So just treat this like a normal equation. You would subtract 7 from both sides and you end up with square root of x equals 9. And the way to get rid of the radical would be to kind of undoing a square root, and you undoing it by squaring. And I saw some of you doing this earlier. So the square root of a square root is itself. So I end up with x equals 81. And that is true. If I even try it out, the square root of 81 plus 7 is 16, and that is true. Once you press pause and you try it out on the got it. I found out that x equals 9 in this situation, and when I try it out, it is true. 3 minus 5 is -2, so that is true. All right, we're going to use a radical equation in this one. So this is just a situation of a pendulum of a clock. Ends up with time equals 2 times the square root of the length divided by 3.3. Don't be intimidated by the words. We're basically trying to get to the equation, and now we can use the equation. Okay, so let's see what we found here. We says if the pendulum of the clock completes a full swing in 3 seconds. So we're going to go ahead and substitute 3 in for the time, and we're looking for the length of the pendulum. So what I know is it's going to be 3 equals 2 times the square root. I'm going to go capital L on length just so I can see it and not lose track of it. Okay, so first thing I'm going to do on this one is I'm just going to do like I do with a normal equation. I'm trying to isolate the variable, but this time there's a radical in it. Not too bad. 3 divided by 2, I'm going to the decimal on this one just because I see a decimal in my answer, in my problem, 3.3. So just so I can keep everything consistent, I end up with the square root of length divided by 3.3. The plot thickens here. In order to get rid of my square root, I'm going to square everything. 1.5 squared is 2.25 equals length over 3.3. Multiply everything by 3 3/10. End up with 7.425 equals my length. So my length is 7.425. I'm going to look up here. What am I talking about? Centimeters, inches, seconds. The length is this going to be in feet? In feet. There it is. Okay. So my answer is 7.425 feet. I bet you get to do one of these. Haha. You don't. What? You don't get to do one? Aw, shoot. There's got to be one in here that you get to do. Where is it? All right, I guess you don't get to practice that one. So let's just go ahead and move on to problem number 3. You know, you should practice that one. You practice this one. Okay, here, I'm going to give you one. Okay, let's go ahead and you solve this one. Here is your got it. Got it! Okay, you try it. Same situation, same equation, but let's go ahead and give the time to be 1 second. So press pause and your time is, instead of 3 seconds, it's 1 second. All right, when I work this out, my length is 0.825 feet. So under a foot for this guy. I hope you got that too. All right, what do we do if we're solving radicals with expressions on both sides? Okay, and this can happen, and we don't have to be intimidated by this because we know that if we just, whatever we do to one side, do to the other. So let's just go ahead and square both of them. And when you square square root, you end up getting itself. And we end up with t plus 5. Okay, And then we can go ahead and just start working through this one. I'm going to subtract t from both sides. I end up with 4t minus 11 equals 5. I'm going to add 11 to both sides. 4t equals 16. I'm going to divide by 4. Now, a bunch of you do this stuff in your head where you start doing some things, so just be careful when you do that so you don't skip any steps in this one. I get t equals 4. And that indeed is the correct answer. And look at here. Check it. You got it. Press pause. You see what you can do. All right, I squared both sides to clear out the square roots. I simplified. I'm doing everything to, whenever I do to one side, I do to the other side. Got to be fair. Got to be even. Got to keep it equal. And I got x equals 7. I hope you did too. Okay, when you solve an equation, now this is where the extraneous stuff comes up. Sometimes your answer doesn't work. Like in this, if your original equation is x equals 3, if you square each side, x squared equals 3 squared, your new equation is x squared equals 9. So the apparent solution is 3 and negative 3, or 3 or negative 3, but negative 3 does not satisfy the original equation, and we'd call it extraneous, or an extraneous solution. So this is why we need to start checking our answers. Rather than just getting an answer, now when we're dealing with radicals, we need to check it, see if it indeed is true. And I'll show you an example here on problem 4. Okay, so I have n equals square root of n plus 12. What I am going to do on this one is I am going to square both sides to 10 to the radical and end up with n squared equals n plus 12. I'm going to, okay, now take a look at this. So I'm going to subtract n and I'm going to subtract 12 from both sides and end up with the equation of n squared minus n minus 12 equals 0. Now this looks like something we've done before. Going to do some factoring. And here's something I saw a person do the other day, and I thought it was pretty neat. They drew an x on the side, and they looked at negative 12, and they looked at the negative 1, and they were asking themselves, what times what gets me the negative 12? And what plus another number gets me negative 1? And I can see it's going to be negative 4 and 3. So that gives me my equation. N minus 4. Actually, it's my two binomials is what it gets me. And when I break these out, I can see that n minus 4 equals 0 and n plus 3 equals 0. And I'm going to end up with n equals 4. And n equals a negative 3. But like I said, we're kind of looking for the extraneous answer, so we're seeing if it is true. I'm going to go ahead and plug this back in. So let's try the 4. So putting it back in my equation, does 4 equal the square root of 4 plus 12? Does 4 equal 4 plus 12 is 16? That is true. I'm going to try the negative 3. Does negative 3 equal the square root of negative 3 plus 12? Does negative 3 equal square root of, let me look at this one, I'm working with the negative 3, that's 11. No, it's not. Oh, it's 8, square root of 8, and that is not true. So square root of 3 is not a solution to this. All right, so let's look through here, and I am going to go down here and have you press pause. I want you to try to got it. What are the solutions of negative y, ooh, careful with that one, equals in square root of y plus 6. And you're just checking to see, is one answer true, or both answers true, or are neither of them true? Are you looking for an extraneous answer? Pause. All right, when I work out this equation, I can see that I end up with answers of 3 and negative 2. And when I substitute it in, I see negative 3 does not equal square root of 9, which is 3, so that one is extraneous. And 2 does equal 2. So that tells me that this answer is true for this equation with the radical in it. Y equals negative 2. Sometimes you get only extraneous solutions after squaring each side of the equation. In this case, the original equation, ends up with no solution. So sometimes, again, sometimes you end up with no solution at all. And that's why we check it. So in this particular one, I'm going to just start simplifying. I'm not going to square both sides yet. I'm going to deal with this. So I end up with square root of 3y equals 2 minus 8 is negative 6. Now I'm going to go ahead, square both sides, and I end up with 3y equals, and that's negative 6 times negative 6. I'm ending up with 36. I end up with 3, or divide by 3. I end up with 3 divided by 6, and I get 12. So I'm going to plug it in and see if it's true. The square root of 3 times 12 plus 8 equals 2. That's the square root of 36 plus 8. Does that equal 2? That gives me 2, 6 plus 8. Does that equal 2? And then I end up with 14 not equaling 2, and it's my only solution that I was able to work through. So this one, 12 is an extraneous answer, but this one I would say has no solution for this one. All right, you're going to try it out on this guy. I suspect it doesn't have a solution because that's what we're practicing. But instead of just writing no solution, we go ahead and work it out to prove to me that it has no solution. And the reasoning is an interesting thing because if you can see what the reasoning question is asking you, then you can actually find that situation sooner. You can find where you can look at something and go, oh, that's going to have no solution. And then you just got to work on the proof to show it. Let's pause. All right, when you look at this example here, I simplified the 6 out, and I squared both sides, and I end up with 2x equals 16, and I'm checking 8. I substitute 8 in, and I found out that 2 does not equal 10, and this would be no solution. The 8 is extraneous. Now for the reasoning one, how can you determine if that equation, the square root of x equals negative 5, does not have a solution without going through all the steps to prove it yet? What are some of the identifiers early? Well, it's that negative 5. If you're trying to think square root of something is going to equal negative 5, that actually cannot happen. So you can see already that this is no solution, but then you might have to rework it to get some proof. But at least you can tell it early, start seeing this concept early on. All right, there you go. Keep practicing this stuff. It'll get easier and easier as you recognize patterns and things you can do. All right, I'm going to go and write the first 47 digits of pi on my eyelids.